Good morning children and welcome back to your chemistry class. Today we are going to study alkynes in the hydrocarbon chapter. So these are unsaturated hydrocarbons having at least one triple bond between two carbon atoms. Between two carbon atoms there should be one triple bond, right? Their general formula will be what? General formula is CnH2n minus 2, right? Now let us talk about the structure of the triple bond. There is one sigma bond and there are two pi bonds. Clear? There are one sigma bond and two pi bonds in carbon-carbon linkage, right? The two carbon atoms of this carbon-carbon, they in excited state, they show sp hybridization, right? Or they are sp hybridized. So let us see the overlap of the orbitals in say C2H2. Okay, so if you look at the figure over here, the overlap of orbitals in the formation of the bonds in C2H2, we will find here that the sigma bond between two carbon atoms, it is formed by the overlap of the two sp hybrid orbitals, one belonging to each carbon atom, right? Then secondly, you will see that there are two pi bonds between the two carbon atoms and they are formed by the overlap of the unhybridized 2p orbitals, right? And next, if you see the C and H bond formation, that is again your sigma bond that is formed by the overlap of your sp hybrid orbital of carbon atom, that is the C atom or the carbon atom, and one s orbital of your hydrogen atom. Clear? So I hope this structure is very clear to you of C2H2. Now let us talk about the bond angle and bond lengths of this ethyne of C2H2, that is ethyne. So over here, if you see the ethyne, it shows a linear molecule. What kind of a structure does it show? It shows a linear molecule first and foremost. Now look at the bond angle between H, C, C and H. That is this angle over here. This is a straight line which is equal to 180 degrees. This is a straight line, no? This is your 180 degrees. So I'll write over here 180 degree. Then another point that you check, carbon triple bond, carbon bond length, right? This is your 120 pm. This is how much? 120 pm, right? Picometer. Then look at carbon and hydrogen, carbon and hydrogen, carbon and hydrogen. This is 106 pm, right? This is 106 picometer, right? So I hope till here it's very clear to you. Now let's talk about the nomenclature. What do we know about the nomenclature? In IUPAC system, alkynes, they are always named as the derivatives of the corresponding alkanes by replacing that ANE of the alkane to YNE. Okay, from ANE we move to YNE, that is ine. So the position of the triple bond is always indicated by the first triply bonded carbon. I hope this point is clear. Now let us talk about isomerism. What do we know about the type of isomerism that we find in alkynes? Talking about the isomerism. So let us see over here the chain isomers of alkynes. So over here example could be like pent 1-ine, that is CH3, CH2, CH2, C triple bond CH. What is this? This is pent 1-ine, right? And in place of this I can also show you CH3, C, CH3, C triple bond CH. What is this? This is 3-methyl 1-ine, right? So what do they show? They show chain isomerism. Is that clear? This is C5H8 and this is also, okay, so they show chain isomers. Now let us see position isomerism also. For example, CH3C triple bond CCH3. So this is but2-ine, clear? And if we see CH3 CH2 C triple bond CH, this is also but, but it is 1-ine. So the change in the position of the triple bond also explains about the position isomerism. It also shows functional isomerism. How? Let's see that also. If I take CH3C triple bond C CH3, so this becomes but2-ine, isn't it? And now look at the other compound of it. It is CH2 double bond CH, CH double bond CH2. So what is this now? This is called as 1,3-butadiene. So here you can see there is a triple bond over here, whereas here you can observe that there is change in the functional group, that is it has become a double bond or a ene compound. Okay, so I hope you have understood what I want to explain about isomerism. Now we shall move to next. Let us come to methods of preparation. So first method is to prepare alkynes from calcium carbide, right? So for here we take CaO with 3 molecules of carbon and we first prepare calcium carbide, that is CaC2 plus carbon monoxide is formed. Now this calcium carbide is treated with 2 molecules of water and we obtain calcium hydroxide plus ethyne, that is C2H2. Clear? So this is one method of preparing alkynes. Second is from vicinal dihalide. Okay, so now vicinal dihalide, what does that mean? It means that a compound containing 2 halogen atoms on the same carbon atom, they are always termed as gem dihalide. Gem has this word has come from Gemini. Gemini means what? It means twins. Okay, so let's see this. Like for example, if we take CH2 CH2 Br. So this is called as a gem dihalide or a vicinal dihalide. What is the name of this? 1,2-dibromo ethane, right? When this is treated with alcoholic KOH, right? When it is heated with alcoholic KOH, it will firstly remove KBr, plus it is also going to remove water from here. So if water and KBr are removed, what do we get? We get CH2 double bond CHBr. So 1 KBr, okay, and H2 and another O. So we obtain what? We get a vinyl bromide. Okay. Further, when this vinyl bromide, it is treated with NaNH2 or maybe with liquid NH3, right? The temperature that could be maintained is 196 Kelvin over here, and then we obtain what this is called as ethyne. Clear? Now, instead of carrying out the dehydrohalogenation reaction in 2 steps, the reaction can be carried out in a single step alone with the help of NaNH2 in the liquid ammonia, right? So for example, we can see like this also, CH2 bromine, what is this? 1,2-dibromoethane. When treated with, as I said, 2 molecules of NaNH2 in the presence of liquid ammonia at 196 Kelvin, we can straight away get the ethene, triple bond CH, plus what else can we get? Over here, as we removed KBr and H2O, here what are we going to get? We will get 2 NaBr plus we will get 2 NH3. Okay. So this is another method to obtain ethyne. Now next method is here Colway's electrolytic reaction. Okay, electrolytic reaction. So let us see over here. We take potassium malate over here, that is CHCOOK double bond CHCOOK. We add 2H2O over here. In the presence of what? Electrolysis, it is going to give us plus 2 carbon dioxide plus 2 KOH and hydrogen gas is given out, right? So what was this? This is potassium maleate, I hope you can understand, MALEATE. So potassium malate, when treated with water in the presence of current flowing through it, it will form ethyne plus carbon dioxide, KOH and hydrogen gases given out. Okay. Then next one is synthesis of higher alkynes. Okay. In the synthesis of higher alkynes, the lower alkynes are first converted to sodium alkanite by treating it with some metallic sodium and liquid ammonia, or you may also call it as sodium amide. Okay, and then we can obtain the respective alkynes. So let's see, the lower alkyne could be like your ethyne. So let's take this ethyne CH. It is treated with sodium, right? At what temperature? 475 Kelvin, right? and this is going to remove half of the hydrogen molecule. And what is the first product? It is going to give us sodium alkinide. So that is CH triple bond CNA. This is plus, this is minus. This is your sodium alkinide, which further, when treated with CHI, that is methyl iodide, it is going to give us propyne, that is C triple bond CCH3. This is what? This is your propyne, and alkyne is formed along with sodium iodide. Clear? Let's take one more example, the lower alkyne group, that is your ethyne. When treated with 2 molecules of sodium at the same temperature 273, what will be removed? Hydrogen gas will be removed, and again, as I told you, over here it is going to form disodium acetylide, that is Na plus C minus triple bond C Na plus. What is this? Disodium acetylide. Okay. This further, when treated with 2 molecules of CH3I, it is going to give us CH3C triple bond C CH3 plus 2 NaI. So what is the name of this? Which alkyne is formed over here? It is but-2-ine is formed over here. So these were some of the methods of preparing alkynes, right? Now let us also talk about the physical properties over here in this video itself. So the first 3 members, they are gases, right? The next 8 members, they are the liquids, and higher ones, they are always solids. Now all alkynes, remember, they are colorless. What are they? They are always, or maximum, they are colorless. These alkynes, they are weakly polar in nature. One point is, they are weakly polar in nature. Clear? Then they are lighter than water, and they are miscible with, they are lighter than water, and they are immiscible with water, but they are soluble in organic solvents. Okay. So what should I write there? Immiscible in water, but soluble in organic solvents, right? And their melting and boiling point, what do we know about melting, boiling, and the density? It always increases with the increase in the molar mass. Okay. So what did I say? Whether we talk about melting point, we talk about boiling point, we talk about its density. What do we know about it? About all these? They increase with increase in the molar mass of the compound. Molar mass of the compound. Clear? So these were some of the physical properties of your alkynes. What were they? What did we study? That the first 3 members, they are gaseous in state. Next 8 ones, they are liquid, and higher alkynes, they are all solids. Then all these alkynes, they are colorless. Then they are weakly polar in nature. Then they do not dissolve in water, but they easily are soluble in organic solvents, right? Then what else? We talk about their melting point, boiling point, and density, that they increase with the increase in the molar mass, right? In the next chemistry period, we shall be discussing about the chemical properties of alkynes. Thank you for today.